Hey YouTube fam, welcome back to another episode on Code with Annie. Now, this is a very important episode and it might go up to 15 minutes, reaching the 10-minute mark if required, because this is a concept that I want every programmer out there to know thoroughly, because this is a slightly confusing concept. I'm giving you a heads up because you have to focus in this video to understand what I'm trying to say. It's the concept of recursion. Recursion is a well-known concept in programming world, and there is always a need for recursion in certain scenarios. Let me explain you where. So before that, let me tell you what recursion is. Recursion by definition is nothing but function calling itself, okay, again and again until an exit condition is met. Okay, there is a method. The method ends up calling itself and it executes again and keeps on going until there is a certain condition which states that, okay, now you don't have to call yourself. We have got the required result. You can come out of it. That is called as recursion. In simple words, let me put it like this. There is a function, let's say public int get value, okay, and I say it receives, let's say, an integer n, and if n equal to 0, I'm saying return 1, okay, else just call get value for n minus 1. This is just an example to show you what I mean by function calling itself. So if this condition is satisfied, because I'm decrementing n every time I'm calling get value, correct? So every time I call get value, I'm calling with one value lesser than what n was previously called. Let's say I pass initially get value with n 5. Now 5 is not 0, so it goes and calls get value again with 4. 4 is not equal to 0, calls again with 3, 2, 1, and finally it reaches 0 and n is equal to 0 is satisfied, and we break out of this recursion and return 1. So this process is called as a recursion call, and to be very specific, this particular type of recursion is called as tail recursion. Tail recursion because recursion is the last thing that your code will do before your method ends. There's no manipulation of data here. There's nothing else except just the function calling itself. If that is the last line in your code, that is called as a tail recursion call. Tail recursion is an optimized call for two reasons. But before that, I should explain you where the recursion comes into picture. So let's say you have a code base which can be implemented using iteration techniques like while, do while, for loop, and all those things, right? So with that, you can achieve certain parts of logic, but where recursion will come is where you want more readability to your code. Very small pieces of code, you want readability to, you're having certain logic that you're doing, which may not be very complex, but it will look very elegant if you use the recursion technique. Okay. So apart from elegance and more readability, recursion has not much value in the world of programming, but it is still an important concept because in certain places and certain languages like Scala, tailed recursion like this is preferred over using loops like for loops or while. Okay. So that's the reason why this gains a lot of traction. And what it does in every call of recursion is whenever a function is called in Java, it gets put up in a stack. A stack is a data type which can store data one on top of the other. For let's say a stack contains data like 1, 2, 3, 4. Okay. So when I try to get the information out of stack, the way it will be returned is 4, 3, 2, 1. Because you pile up the data on top of one another, right? When you take a basket, let's say, and you try to put data in it, right? When you try to put cloths into a basket, what happens? You put all the cloths in, and when you try to take out, the one that you put last will be the one that comes out first, right? That is the exact principle of stack. So even function calls that you make are basically stored in a stack. Okay. So what happens is when I call this function, in this case, get value gets put into stack. Let's say get value of 5 was the initial call, right? It gets put into a stack. Now I'm saying it's not equal to this thing. So I'm saying get value of n minus 1. So what will happen here is Instead of putting one more get value, it will just remove this one and say get value of 4. The stack will always have a constant get value function instead of adding one on top of the other. That's the reason why tailed recursion it does not retain the original caller stack. It keeps on overriding the one that is already present. So therefore, there is always one element in the stack. And therefore, you will never run into stack overflow exceptions when you use a recursion call like this one, where the recursion is the last call. Let's say if recursion is not the last call. So what you do is you basically say get value of n minus 1. Let's say simply to not make it a tail recursion, all I have to do is just say I multiply this by something like 5. Okay. Now what will happen is I say get value of 5. So what it should do is for this condition, okay, it will say get value of 5 initially when I call it. Then it becomes get value of 4. Okay. Because I'm saying get value of 5, get value of 5 is nothing but get value of 4 into 5. Okay. So I need to compute get value of 4. I can't stop there. So I'll say get value of 4 also I'll add to stack. Okay. Then I will add get value of 3 because I don't know what is the value here. I have to store all of these so that I can circle back and calculate the values one by one. So I'll say get value of 5, 4, 3, get value of 2. Okay. And it will go to get value of 1. Okay. And finally, when it reaches get value of 0 into 5, okay, 0 comes here and it says return 1. So now I know that, okay, get value of 0 is 1. Okay, when I say get value of 0, I know that get value of 0 is equal to 1. So get value of 0 is 1, correct? Now once I receive get value of 0, I have to empty this stack. So how will I empty it? I will start removing the values from the top. I know get value of 0 is equal to 1 because that's what I've written here. Next step what I will do is I will say get value of 1 is nothing but what was get value of 1? Get value of 1 is get value of 0 into 5. Get value of 0 is 1. So 1 into 5 equal to 5. And get value of 2 will be equal to get value of 1, which is 5 into 5, which is equal to 25. Likewise, I'll do get value of 3, get value of 4, and finally get value of 5. This is called as stack unwinding in Java. Basically, I'm trying to take the elements one by one from the top of the stack, which is the last value that I put into the stack. So I will unwind the stack and I will try to remove these one by one until I reach the last thing, which is get value of 5. So this goes on and goes on until you reach get value of 5. Based on the previous value that I've computed, you will compute the next one. Okay, this is a normal recursion. But here, what will happen is if I don't have this kind of thing here, right? Then what I'm saying is, okay, get value of n minus 1 will simply replace 5 with 4, 4 with 3, and there is no adding up on the stack. That is the advantage of tail recursion calls. Okay, this little concept, if this is clear, you have got a very good understanding of recursion if this is clear to you. Okay, if not, feel free to watch the video again from the beginning slowly. It will take time to understand. That is absolutely fine because this concept is like that. But if this thing you're getting, that's it. That's pretty much what recursion is all about. Okay. Let me give you a real-time example in IntelliJ, like we usually do in all our videos, right? We have to write the proper code and execute it. Let's say I create a Java class. I'll call it Fibonacci sequence, the most asked question in many programming interviews, right? It's a very simple but a very elegant recursion logic that we can write to it. It's a Fibonacci sequence. Okay. And one more thing I wanted to showcase here. When I keep adding values like this in the stack, correct? When I'm using non-tail recursion calls, we'll end up getting stack overflow exceptions for very large input values because even the stack is a data type in Java, right? Stack has a limitation to how much it can accumulate in its um, kitty. So you keep adding values to it. At certain point, it will run out of space to put more values on top because you have not yet reached the point get value of 0, right? Suppose there is let's say 1 lakh value of n, right? So it will go on from 1,99,000, it will go on, and finally it will reach a point. By the time it wants to get value 0, it would have already run out of space to even put more things on the stack. Okay, your basket is basically full. That is in Java's terminology called as a stack overflow exception that you usually see in many of the cases, right? Even in iteration calls like um, looping constructs, right? When you don't have a certain exit condition, you might run out of stack and it'll get stack overflow exception there as well. Okay, that happens most of the time. So in recursion calls, this is very common because recursion call saves the function itself in the stack, right? So at some point it'll run out of memory. So keep that in mind and always prefer to use a tail recursion call. Don't have any manipulations here. If at all there's a manipulation like that you wanted to do here, you can put a traditional accumulator or any result value from where you can store it. I'll show that in the example that I'm trying to show. Okay, this is Fibonacci sequence, and you guys know what Fibonacci sequence is, I hope. If not, for the uninitiated, Fibonacci sequence is basically sequence of integers where one integer is the sum of the previous two. Let's say it starts with 0 and 1, okay, always. And the next value will be 0 plus 1, which is 1. The next value will be 1 plus 1, which is 2. Next value is 2 plus 1, which is 3. 3 plus 2, 5. 5 plus 3, 8. 8 plus 5, 11. 13, sorry. So it goes on like this. So 0, 1, um, 0 plus 1, 1, 2 plus 1 plus 1, 2, 3, 5, 8, 13. Yeah. It goes on till whatever is your target. Like let's say you want to find Fibonacci sequence up to 100, you can keep doing this. But till 100 iterations, what is the entire sequence that generated out? So this is basically the Fibonacci sequence. Now, if you want to generate the sequence for value up to n, how do we do it? Using recursion. So let's say we'll have a method called recursion logic. Let's say we'll do this. Public int. Okay, so what are we looking at? So we need to have clearly defined starting parameters, right? So we know that we'll start with int first value as always equal to 0. Okay, there's int second value which is going to be 1. In any Fibonacci sequence, it's always going to be 0, 1. That's your starting point. Okay, now what I'll do is I'll say my int next, okay, or the value next is going to be first plus second. Okay, this is the ideology that I'm looking at. And let me show you in the comment style. So what I'm intending to do in my recursion is I'll find next by adding first and second. And once I found my next, what I'm going to say is first will be replaced by second and second will be equal to next, basically. So what I'm saying is I found 0 plus 1 as next value. Now, what is going to be the first one? The first, that is, I'm replacing this variable with what is the value of second, because I'm going to add up. I found 0 and 1, right? I found this value. Now what I'm saying is for the next value 2, I need to have this one as my first and this as the second. Okay. In order to do that, I'm just reassigning it. I'm saying first will be equal to this, which is second, and second will be equal to next, whatever I found recently now, which is this one. Okay. So this is what I'm going to do in my iteration, in my recursion call. And this is going to go on until the value n, or up till the nth number to which I want to generate the sequence. All right. With this logic in mind, always have this kind of rough drafting when you try to implement a certain code. Okay. This will help you to understand your logic more clear. Put that in the comment. Multi-line comments are written in Java using /*. Once you put /* and enter, it will automatically complete with // and you can write all commented logic here. So this will not execute. These are just Java doc comments. Okay. Now what we'll do next is let's try to write the method public. Okay. Not void. I'm going to return a string. Okay. And I'm going to say get Fibo sequence. I'm just putting a method up till int n value. Okay. Okay. Now I'm going to have to find the sequence and store it somewhere, correct? So what I'm going to do is the sequence is a sequence of integers, okay? But it's going to be returned as one single sequence, right? Like this. So let me store it in a string. But simply appending to a string is not quite a good approach in Java. So what we'll do is, in order to build a huge string like this, there is something called a string builder. So I'm going to say string builder space builder, okay, or sequence equal to new string builder. Okay. Now I'll say string builder sequence dot, sorry, and what I can do here is, in the sequence I can simply add append. Basically, string builder can have the append method in it. I'll append the first, okay, first, and then I'll append a comma to it. Okay. So instead of saving it as integer, let me do the honors and put that as string itself. Okay, and put it like this, because I want comma separated value, so you'll know which number is the one that's got generated next, right? So first and second, I'm going to put like 0, 1, and I'm going to append first and sequence dot append second. Okay. Now I've added this to the string builder. Now what I'll do is, I'll create one more private method, which is the one that we are going to have the recursion on. And say get sequence. Okay. And to this, I'll pass in this integer which I've received, the limit n. Okay. And also I'll pass this string builder object. Okay. Which is sequence. String builder space string builder. Okay. Or I'll say sequence. Okay. Now here what I'm going to do is, if n is equal to 0, this is always my exit condition. Remember you have to give your exit conditions first whenever you try to write recursion logic. So my exit condition is, when I reach the value n0, just return sequence dot toString. Sequence dot toString. So string builder will build it and it will create a string and it will return it back. Okay. Else, if n is not 0, what I'm going to do is, I have to find out what is the next value, right? So I have 0 and 1, correct? So I'll have to replace them. Okay. So what we're going to do is, let's say, okay, instead of this, I think we'll just keep it as integer. That I think is fine, because we have to compute the summation on this. Let's keep it like this and it's fine. Here we will do the manipulation. I'm going to say first, okay, it has appended it, and I'll say um, can append another value to it. So I can append the comma here. You can keep adding append continuously by chaining it. This is called as function chaining. So every time I do an append, it will append and return back the same string builder object to me. Okay, sequence object. So sequence.append will first add 0, then it will add comma to it, then it will add 1, it will add comma to it. Okay. So what I'm going to do is, I'm going to say int next is equal to first plus second, the same logic that I wrote in the comments. Okay. First will be equal to second, and second will be equal to next. Okay. Once this small computation is done, the last thing I'm going to do in my code is call the recursion. So you get sequence, okay, n minus 1, comma, sequence dot append next dot append the comma. Okay, as you can see, immediately you'll get a small icon here saying that this is a recursion call, because recursion, and specifically this is a tail recursion because that's the last thing you're doing, okay, in your call. So I'm doing this, I'm calling get sequence. Okay, so this is done, this is done. Oh, I have to put a return statement here, right? That's it. So my recursion logic is complete. If you can observe, this was the logic that I wrote in the comments here, right? So same thing I've applied here. And I'm calling get sequence with n minus 1 appended to next, and sequence is appended with next value, and then the comma is there. I'm going to call get sequence from here. Okay, I'm going to say n, which is the initial one I passed, and sequence. You might be wondering why I could have simply done the same thing with this function, right? I could have made this one recursive, but no. The reason is, this is basically the principle of abstraction, right? You don't want the caller function to know that there's a string builder manipulating the values for you. According to the caller, all he needs to know is I pass a value of n, I'll get back a sequence of Fibonacci numbers. That's it. That is my requirement. Nothing more than that. Okay, with this out of the way, let's complete this code. So the code is completed and we just have to call this function. Let's go to main and let's say, I want to say Fibonacci sequence, space Fibonacci sequence equal to new Fibonacci sequence dot get Fibonacci sequence. Let's say I want to get till size 6. Okay, so 6 integers I'll get. Okay, I'm going to print that out for you and let's run this. Code is compiling. Let's give it a minute. Yeah. And here we go. 0, 1, 1, 2, 3, 5, 8, 13. All right. So this is how the recursion logic can be applied and this is how it works. Have an exit criteria and make sure you call the recursion as a last thing in your code base. Okay. And this is called as accumulating the value because initially I set the sequence with only 0 and 1, right? Now, as and when my recursion is getting called, I am updating my string builder sequence with the new value I've computed. So end of the day, when I return the sequence.toString, it would have already obtained all the values till 13. It doesn't have to do a stack unbinding because the caller stack is getting replaced every time with a new stack. Instead of getting added on, it just gets replaced. And this is the reason why it's the more efficient way of writing a recursion logic. Hope you liked this video. If you liked it, do hit the like button, subscribe if you haven't already, hit me up in the comment section if you have doubts on this and I'll be happy to clarify and I'll see you guys in the next video. Bye bye.